Okay, what is heat of transformation means? Normally, I will consider the example of water. For water on the temperature scale, there are 2 points which are very important. Suppose this is a thermometer. On the thermometer, we have 2 points. One is, and suppose this is the Celsius scale. On this Celsius scale, 2 points are very important. One is 0 degree Celsius and the other one is 100 degree Celsius. Suppose we have a cup of water and inside this cup we have of water, and we place this water in an environment such that the environment temperature is 0 degree Celsius. If we bring the temperature of this environment or this surrounding, suppose this is the surrounding and this is our system under observation. If we bring the temperature of the surrounding to 0 degree Celsius, then if the water is in liquid form, then it start freezing. So on this glass we have both liquid water as well as ice. So at 0 degree Celsius, the water has two states now. One is freezing water, which is ice, and the other one is melting water, which is liquid. So here the temperature doesn't change, like the temperature is 0 degree Celsius, but the state of the water change from ice to liquid or from liquid to ice. There are two phases of water. One is ice and the other one is liquid. One is freezing phase and the other one is melting phase. Now I will consider another example. Suppose we have again the same glass of water, but at this time we covered the glass with a cover shown here, and this is our system, okay, which is under observation, and we place this system in an environment. This is the environment. If we raise the temperature of this environment to 100 degree Celsius, then this water start boiling and the water molecule start evaporating. So it start evaporating and become as a gaseous state. These gaseous molecule will accumulate on this cover, and once the accumulation become more saturated, then these gaseous molecule become liquid again and fall to the water again. So we have condensation. We keep the temperature constant 100 degrees Celsius, but at this 100 degrees Celsius we have both evaporating water and we have condensation water. So evaporating water is basically in gaseous form, and condensation of water is basically liquid form. Gaseous, this is gaseous form. So again at 100 degrees Celsius we have two states of water. One is gaseous state and the other one is liquid state. We have two phases of water. One phase is gaseous phase and the other one is liquid phase. So we can say that at melting or freezing, as well as at evaporation or condensation, the temperature of system doesn't change. Like the temperature is always 100 here. During evaporation and condensation, the temperature is always 0 degrees Celsius. During freezing and melting, the temperature doesn't change. The temperature of the system doesn't change. Only change of state or phase occur, like freezing to melting or melting to freezing, or evaporation to condensation or condensation to evaporation. So we call this state as phase transition. These states, like from evaporation to condensation, condensation to evaporation, is called phase transition. And the heat energy absorbed or released during this phase transition is known as heat of transformation. And the heat absorbed or released during phase transition is called heat of transformation. Now, mathematically, heat of transformation, heat energy released or absorbed during phase transition, is proportional to the mass m. If we remove this proportionality sign, we will introduce a constant which I will represent by L times mass. This L is called latent heat. Now this latent heat L is called heat of fusion, LF. At freezing or melting, and L is called heat of vaporization or latent heat of vaporization, denoted by LV at evaporation and condensation. Generally, this L is called latent heat, but if we calculate latent heat during freezing or melting, we call it latent heat of fusion, LF. And if we calculate this latent heat during condensation or evaporation, is called latent heat of vaporization. So this is all about heat of transformation. In the next video, we will derive a relation between CV and CP. Heat capacity at constant volume and heat capacity at constant pressure. Thank you.